Alrighty, hello. Here are the couple of the problems I'll work through for the mixed projectile problems. I chose number 1 to do, number 2 to work through, and also down at the bottom, number 4 to work through. Those 3 problems will help you get the other ones that you did not get. So I'm using the worksheet that I used that has the answers only on it, just so as we go through, we'll just double check to make sure that we actually got that same answer. So for our first problem, it tells us that a pool ball is leaving a 0.6 meter high table with initial horizontal velocity of 2.4 meters per second. So because this is telling us that it is horizontal, we know that this velocity that it gives us, this number, is velocity in the x direction. All right, sorry about that, had a little interruption. So that means that this velocity that we're given right here, this 2.4 seconds, this happens to be our velocity in the x direction. So when we want to determine the time required for the ball to fall to the ground, so think of what direction falling is. Is falling moving horizontally, or falling to the ground, is that moving vertically? So to fall to the ground, all we need to know is how high it is falling. So think of falling to the ground as a vertical distance. So we're going from the top, of the table down the 0.6 meters. So to find out our time to fall, we're going to use our equation for delta x equals 1/2 at squared. All right, I left off the second half of that equation. So that second half of that equation is plus v initial t. But notice, if we're going in purely the vertical direction, and we just said that this number here is all in the x, is there anything, is there any velocity left over of this number that would be in the y direction then? And that answer is a no. So I'm going to go ahead and erase that part, because that's all that's going to determine our time. So we know that this object is falling 0.6 meters. It does so with gravity. And our time squared, which is what we're trying to solve for. So if we set up this equation then, we're going to move the 9.8 and the 1/2 over to the other side. So we're going to get some work that looks like 0.6 divided by 4.9. That's going to be equal to t squared. So we're going to have to take the square root of that number. So we come up with the time that's right over here of 0.35 seconds. So just to reiterate, vertical distance. We want to know just the vertical, how long is it going to take it to fall? This piece of information, this velocity in the x, was not needed to do part A. We need it to do part B now. So part B, it asks to find, again, look at the words, horizontal distance. If this is a horizontal distance, it gives me horizontal velocity up here at the top. So we found the time in the previous problem for it to actually fall. That's the same time that we're going to use to figure out how far is it going to go from the edge of my table. So my ball is going to roll down. How far is it going to go from here to the edge of my motion? So our equation we have is velocity times time equals distance. So I use velocity in the x direction because that is what's making our ball travel horizontally. So that velocity in the x is the one that we were actually given in the problem. So in this case, we're going to take the 2.4 and we're going to multiply it times the 0.35. So we get that this object is going to travel 0.84 meters from where it started. So it started here at the edge of the pool table, and it's going to travel 0.84 meters from that leg of the table. All right, let's look at number 2 now. So number 2, we're kicking a soccer ball. It gives us that it's kicked horizontally. So automatically from the previous problem, what does that mean about the velocity of the ball? So that means that all of the velocity is in the x direction. So when we solve for this velocity down here, which we have the answer for, we are solving as if all of our velocity is kicked straight horizontally off of that 22-meter high hill. So I'm going to put a little picture over to the side. And on that picture then, so let's put it over this way so I got some room to work on the other side. So this is 22 meters high. And we know that when this ball is kicked, it's going to be kicked straight horizontally. So that we're trying to figure out what that initial horizontal velocity is. And we know that this object is going to travel from its starting point, so it started, here, it's going to travel along the ground 35 meters. So, let's see. From our previous problem, we're going to kind of use the same steps that we used there to help us solve this problem. First thing we want to do is we want to determine the time, because we can take a distance and a time and solve for velocity. But I need to know the time. So first, I want to know the time that it takes this object to fall. So looking at the previous problem, we did this step right up here. So we're going to use the same exact thing to solve for our time down here. Remember the time to fall. If we think about the word fall, means up or down. So if we're falling, we're going straight down. So we want to use the 22 meters. So our equation to find time, same one that we used before, we're going to plug in this case, the 22 meters, our acceleration, and we're solving for the time. So just like up above, we'll take the square root of that number. So we'll have 22 divided by your 4.9, and we'll take the square root of that number. So my time comes out to be 2.12 seconds. So that's how long it's going to take my soccer ball to go from this location all the way down to where the ground is. Now I can use to find my velocity the same equation that I used right here. Because I know horizontally, horizontal stays constant. So I know that this object is going to travel that same horizontal velocity, because that's what it was kicked at, all the way down until it hits the ground. So I can use that same equation that I did up here in part B to solve for my velocity for the soccer ball. So I'm going to take my 35, hang on a second here. Yes, my 35, and rearranging the problem, I'm going to divide by my time, which I just calculated, of 2.12, and that's going to equal my velocity. All right, so we do get our velocity then of 16.5 meters per second. Alrighty, scrolling down to number 4. I chose to do number 4 because it involves an angle. It has an angle of 28 degrees. So just to initially sort of draw the picture, all right, our long jumper is leaping. Let's do it a little bit bigger. So our long jumper is going to leap up, he's going to have a trajectory, and he's going to land some distance away. So we know this initial jump was at 28 degrees, and that he did this jump at 12 meters per second. So we want to determine the horizontal distance of our long jumper. So from previous problems, if we're asking for horizontal, think of what direction horizontal. Is it the X or is it the Y? We need to solve for that component that you're thinking of right now. So to find B in the X, because that's our horizontal. So if we have our triangle, if we have a side, and an angle, we got a SOHCAHTOA. So for this problem, just stick it down here at the top. We need to use SOHCAHTOA to find that velocity in the X first. So if we have adjacent hypotenuse, we'll use cosine to first solve for velocity in the X direction. So cosine of 28 times 12, oops, calculator error here, cosine of 28 times 12. So we'll get an initial velocity in the X direction. So this is not solving for distance. Notice your unit right here. This unit goes along with this number that's down here. So I know some of you were confusing this number with your answer. Notice our units. We can't switch units and change to a different one. So that means the velocity in our X direction is 10.6 meters per second. So let's look back at our problem, and what we want to determine is the horizontal distance of the long jumper. So we know how fast he's going, so that speed along the bottom will carry him all the way over to the end point. But if I think about our previous problem up here, where we found horizontal velocity, horizontal distance, notice our equation that we have. Velocity times time equals distance. I don't have time in number 4, but I can figure it out. So our next step is we want to figure out his time. So time, things going up or down. So let's think about this. The time that it takes it to go from the ground up to the air, and of course, back down. Notice the direction that I drew these arrows. It's going straight up and straight down. What direction is our vertical direction? Hopefully you said the Y direction. So to figure out this velocity right here when it leaves the ground, I need to solve for my Y component now. Because I know that Y velocity will start here with my dot and travel up to where my velocity in the Y direction at the top is going to be 0. And I can use also acceleration to help me to figure out that time. But first I have to use my SOHCAHTOA and figure out that velocity in the Y direction. So if I use my sine function, 28 sine times 12, I get 5.6 meters per second. So in order for me to figure out how long it's going to take him to go from the bottom to the top, I'm going to use my final minus my initial over my acceleration equals my time. So I need to take my 0 of final, 5.6 of my initial, and negative 9.8 for my acceleration. So I get a time that he's going to be in the air. Remember, this is halfway. We just went up. Think of this as time up. this will be 0.5